Imagine buying a robot. That becomes too small for the job. Normally, you'd replace it. But what if the robot simply built itself a larger body? It sounds impossible, yet researchers are already developing robots that can change their own physical structure without human hands. Not by growing skin or bones, but by rearranging modular parts. Instead of being built as one permanent machine, these robots are made from individual modules. Each module can connect, disconnect, rotate, or attach to others. Think of them like high-tech building blocks. Alone, they're simple. Together, they become something entirely different. Need longer legs? Add more modules. Need extra strength? Reconfigure the body. Need to fit through a narrow opening? Shrink into a completely different shape. Some experimental systems can even replace damaged sections without rebuilding the entire robot. And honestly, that's what makes this technology so fascinating. For decades, humans have designed one robot for one job: a warehouse robot, a rescue robot, a construction robot. But modular robotics changes the question. Instead of asking, "What robot should we build?" engineers can ask, "How should this robot change?" Research groups around the world have already demonstrated robots that crawl, roll, stand, and transform into entirely different machines using the exact same modules. The possibilities are enormous. Imagine disaster response after an earthquake. A robot begins as a large vehicle capable of carrying supplies. Then it reaches collapsed buildings. It separates into smaller robots that crawl through tight spaces searching for survivors. Later, those smaller robots reconnect into one larger machine to remove heavy debris. One system, multiple bodies. The military is also interested, as are space agencies. A modular robot sent to another planet could adapt itself depending on the terrain, instead of relying on one fixed design. Of course, the technology is still in development. Building robots that can reliably connect, communicate, balance, and coordinate dozens of moving modules is incredibly difficult. Every connection has to work. Every movement has to be calculated. One mistake can affect the entire structure, but researchers continue making progress every year, because adaptability may become one of the most valuable abilities any robot can possess. And honestly, that's what makes this technology feel different. We've always imagined robots becoming smarter. Maybe the next step is becoming physically adaptable too. Because the future's most powerful robot might not be the strongest or the fastest. It could be the one that builds exactly the body it needs.